Good evening. My name's Steve Marvel. I'm a survival specialist, and this evening I'm going to talk to you about heat and specifically surface area. Um, we have here a lamb steak, which is nice and is in fact my dinner. However, a little while ago it was frozen, which was rubbish and would have spoiled my tea. But it's on this metal plate, which has got grooves in it and is off the floor because of these little surface, because of these little feet. Now, what's that done? And that has allowed my frozen lamb to thaw really, really quickly. And the reason that is because it is effectively a heat sink, but it's working the other way around. The universe wants everything to be the same temperature. In that, you probably know that if you stick an ice cube in a glass of your favorite beverage, then it will ultimately melt. And the reason it melts is because it wants to be the same temperature as the Coke, and the Coke wants to be the same temperature of the ice, and the Coke wants to be the same temperature of the glass, and the glass wants to be the same temperature of the room, etc. It wants everything to be the same temperature. This is why the washing up bowl full of washing up always ends up the same temperature as the room, because everything gets moved to the same temperature ultimately. Now then, the way this heat sink works, you'll find them normally on computer processors, and they're lots and lots of little sticks. What that's doing is your processor heats the heatsink. The heatsink's got massive surface area, and what that means is that the exposure of the unit to the air, where we're going to have the evening of heat, is huge as compared to the surface of the processor. And this is what's going on here with all its grooves and all of that. It's making the surface area of the frozen lamb much bigger than it actually is. And consequently, it's having a more effective heat exchange with the air, and it's becoming room temperature. It's not just thawing, it's specifically becoming room temperature. Now, to illustrate another lamb point, is if you have your lamb joint, huge joint Sunday dinner, to get the internals of that to be room temperature is really, really difficult because it's so big. And that's you've got to have the center's got to be the same temperatures of the edge, the outside, and the outside, and the outside, the outside. However, you can imagine if you cut that into much, much, much smaller pieces, you have increased the surface area dramatically. And consequently, because you've increased the surface area of this lamb leg, if you like, or turkey, or whatever it is that you're cooking that's frozen, because you've increased the surface area, it now has a better chance of getting temperature the same with the air, the room temperature. And that is just an illustration of another time when the surface area is getting the cold thing up to room temperature, as opposed to the microprocessor in the computer, which is trying to get to room temperature from being too hot. Now then, how does this apply elsewhere? Well, there's a long-standing argument as to whether or not if you have ice in your cooler with your beers in it, in your fridge box type thing that you go camping with, is whether or not when the ice melts, you should or otherwise take the water out. Now then, the thing is about water is it's a brilliant conductor, and there's lots of it, and it's all jammed together. Unlike air, which is a conductor of heat, but there isn't very much of it, yeah, as compared to a load of water. One of my options with this would have been to put it in water, and this is a normal technique for defrosting things. You stick it in a load of water, and ultimately it becomes the same temperature as the water, and the water becomes the same temperature of the room. It's not as if the water itself becomes any colder, because, and I'm sure you've heard the phrase pissing in the sea, is that the water, it's got much more surface area and is in contact with the air, the side of the sink and all of that. And that's got a much better chance of getting to room temperature. And the little bit of cold that's being exchanged with the water in the sink is then dissipating into the water, and there it goes. And so the question with the beers is, do we take the water out of the cooler with the ice? Well, the answer is yes, you take the water out of the cooler, because if your beers are sat with ice, that's great, because the ice is cooler than the beer, and which means your beer will cool down because it's trying to get to the same temperature as the ice. And the problem with water is that if you try and get everything in water, you'll quickly, and this is the thing, is quickly get everything to change into a uniform state of temperature. You'll find, for instance, if you put an ice cube in a glass of water and another one on a surface, you'll find that the one that's in the water, or the whiskey, if you're a heathen, will ultimately, the one in the water will thaw quicker, because of the the fact that the glass of water has got a much bigger surface area than the ice, and the ice is exchanging heat with the water, and the water is dissipating that heat into the air, and everything becomes room temperature. And that's the case. Now, if we're out in a survival situation, or if we're just in camping, then we need to keep warm at night. And the room temperature is the air temperature, the ambient temperature, which is as cold as hell. 3 o'clock in the morning, that is the coldest point of the night. And so if you are in the Arctic or wherever you might be, or even it's just bloody cold because you're in Britain, where I am, if you're going to get cold, 3 o'clock in the morning is the time to do it. So you need to be in a situation where you're not going to exchange your heat with the outside world. Now, how do you do that? Well, the body, thankfully, generates a load of heat by itself. And we like to trap that in our sleeping bag. If anybody's wearing clothes in a sleeping bag, they need a different sleeping bag, just saying. So that air, that warm air, gets all trapped in the sleeping bag. And if your sleeping bag is too good and you're not dissipating the heat out of your sleeping bag, then you're going to get bloody hot, which is no good. However, you'll find that there exists a temperature, a decentness of sleeping bag, which will allow you, because we as humans can tolerate a range of temperature and cope with it through sweating and shivering, depending on which way we're going. We as humans can cope with a certain range of temperature, and if that range of temperature is existing in the sleeping bag, then we're fine. However, if it's dissipating too much, too quickly, then we're going to be in trouble. And so, what is going on here? We have a certain surface area, and the surface area we're dealing with is our bodies, and that is emitting the heat, radiating the heat, conducting the heat out of our bodies into the sleeping bag, and the sleeping bag is insulating it. So it's trapping the heat. And there's actually a shed load of heat that comes out of the human body, which you'll find if you're in a party. The room gets quickly quite warm. So here, on that, this is how central heating works, is you pump a load of hot water into a watery system, and the radiators look like heat sinks, and they are hotter than the room, so they conduct the heat, and because it's a continuous supply of the same temperature water, you can't cool that down if you are the air. So the air naturally gets hotter and hotter because you have this continuous supply of heat, which is the antithesis of this continuous ambient temperature or water temperature or room temperature, which is of the greatest scale. So there you are in your sleeping bag. Then the body can we've got a reasonable range which can cope with. However, it gets colder and colder and colder, and you are dissipating heat into the sleeping bag, and the sleeping bag has a finite surface area, and a measurable surface area. And so what do we do about this problem? Because that surface area is you're going to lose the heat via the surface area of your sleeping bag. Well, this is dead simply where you start huddling up. The point at which huddling up, bringing your arms in, bringing your legs in, etc., you are reducing your surface area. You are becoming the frozen leg of lamb, the center of you, certainly the center of you. The body likes your core temperature to be particularly 37 ish, which is, and it's the case that your outside of your body can get a lot colder, but it's the inside of the body that needs to stay the same. So if you're all huddling up, you are reducing your surface area. So the conduction, that's a stupid word. You are conducting less heat to the outside world, and you will consequently then hopefully end up within that range temperature of tolerance which we can as human beings cope with. Now we have getting more. This is very, very simple similar to the way that mittens work versus gloves. The surface area hand is huge compared to the surface area of mittens, which is basically just a glove with no gaps. And that is the perfect illustration, because you can see massive surface area as opposed to smaller surface area, and so the conduction of heat is less. And so the moral of the story is smaller surface area, less heat go, basically. And in terms of this frozen leg of lamb, actually this is steak of lamb, it is frozen and it wants to be the area temperature, so increasing its surface area means that they will even out, because through the process of entropy the world the universe wants to be the same temperature everywhere. I hope that this makes sense and will aid you in your beers in the cooler, in your survivability and your ability to sell steaks. And so until next time, I shall say goodbye. Do feel free to like this if you got this far. Chances are you did. So subscribe for random stuff that I talk about all the time, largely survivals, a bit of vlogging, etc. Sometimes in the kitchen, sometimes sometimes outside. There's a lot of wild food going on. If you want anything specific, stick it in the comments. If you want to talk about this, stick it in the comments. I read all of the comments. I reply to as many as I can. So, beautiful people, I'm going to eat this steak now. And so, until tomorrow.